Alright, so this is NCCER, Electrical 4, Module 2, Healthcare Facilities. This one's going to be a bunch of just mostly requirements that healthcare facilities have to maintain. They even talk a little bit about how like Hurricane Katrina changed some of the process that we have for maintaining healthcare emergency power and stuff like that in this chapter. So I'm going to start off on page 1, types of healthcare facilities. You got different types of healthcare facilities. Let me pull up my PowerPoint. So, kind of 4 different types: ambulatory healthcare, occupancy, hospital, limited care facility, and nursing homes. So they're all governed by Article 517, which is my first highlight. Trade terms: inpatient, outpatient, throwover. That's the only one you probably don't know. A transfer switch used for supplying temporary power. But my first highlight is on the right-hand side, second paragraph on the right-hand side of page 1. The installation of electrical systems in healthcare facilities is governed by NEC Article 517 and NFPA 99. They go through and talk about what different the different definitions for like ambulatory healthcare, occupancy, hospital, limited care, nursing home. I do have a highlight out of this section. Pretty much it's just on page 2. I've got bullet point: hospital is underlined, and then right under it, 24-hour basis. Next bullet point: limited care facility, right under it, 24-hour basis. Nursing home, 24-hour basis. If you go back and look at the ambulatory health care occupancy, they do not provide, it provides an outpatient basis, which means people aren't staying there overnight. So you just need to know that the hospital, limited care facility, and nursing home, all 3 are open on a 24-hour basis, and that's what they're like, and that's what the rules and regulations follow for them, because they're open at night. 110, essential electrical systems. Just to know the first sentence, I don't have to highlight it, but it's good to know. In a healthcare facility, power is divided into 2 categories: non-essential and essential electrical system. So EES. So that's what's important. So you have like an EES1 and EES2. Next paragraph, second sentence is highlighted. First sentence goes right along with it. You probably need to know the EES, or again, essential electrical system, separated into the equipment branch and the life safety branch and the critical branch. So second sentence is highlighted. The equipment branch consists of those items that are needed to operate the facility but are not directly related to patient care, such as the facility's telephone system. So telephone system doesn't relate to patient care really, but that is part of the equipment branch to make sure the like nursing home can run effectively. The immediate next couple sentences are a separate highlight. The life safety branch and the critical branch consists of those items that are essential to patient care, or patient, out to the side of the rope, patient care spaces. So the life safety branch takes care of patient care spaces. The life safety branch supplies power to those items needed to ensure safety of the building occupants as well as patients. It's the life safety branch. Skip a sentence, and I've got the last 2 sentences in that paragraph highlighted. The critical branch. So you've got the equipment, the life safety, and the critical branch. Last one. The critical branch supplies power to areas that are directly related to patient care. These include pharmacies, emergency rooms, intensive care units, and so on. Shown in figure 2. So they have this picture in figure 2 that shows the different branches. So your normal source of power comes in, feeds all the equipment branch, critical branch, life safety branch, but your alternate source, so this would be like your generator, feeds these three. It doesn't feed your non-essential loads. Non-essential loads are only fed by your normal source of power, which in our case would be power coming from Entergy. Page 3, the second full paragraph on page 3, first sentence is highlighted. The NEC and NFPA 99 both require that the emergency system automatically restore power within 10 seconds of power interruption loss. So power is lost for 10 seconds, you have to start, emergency power has to come on within 10 seconds. Moving on to page 4. Going into, like I said, there's two different types for the EES, or essential electrical systems, type 1 and type 2. Type 1 is the most stringent, so it goes through, and these are the two different types. So type 1 is the most stringent, used to supply critical care or life support, and must automatically restore power within 10 seconds. Type 2 is used to supply a lower level care, as in a nursing home. On page 4, first sentence, on page 4 in 111, type 1 is highlighted. Type 1 EES is required in any facility with critical care unit or that admits patients requiring electrical life support equipment. That's in type 1. Section 112, type 2 EES, first sentence has two highlights that come out of it. First sentence, many nursing homes and limited care facilities require type 2 EES. Nursing homes not as critical as a hospital, like a hospital intensive care unit. So they can use type 2 EES. Got a couple more highlights about type 2. Going on to page 5. The second paragraph in the top right of page 5, last sentence is highlighted. A single transfer switch. So a transfer switch is what switches from normal power to emergency power. A single transfer switch will serve one or more branches of a system in a facility with a maximum demand on the type 2 EES of 150 kilovolt amps, as shown in NEC informational note figure 51742B. So if you have a single switch, it can only supply up to 150 kilovolt amps. Skip a paragraph, and I've got the next paragraph highlighted. This is, out to the side I wrote, this is for type 2 EES, which is what section we're in. The life safety branch must be installed and connected to an alternate power source. So that's the life safety branch of a type 2 EES, so that the design functions are automatically restored to operation within 10 seconds after normal source interruption. So that, in type 2, covers the following bullet points, and I wrote an arrow down to the fourth bullet point, which is exit direction, and exit signs. So within 10 seconds, exit signs have to come back on in these type 2 EES systems. Moving on to page 6, still in the type 2 EES systems. Bottom left of page 2, talking about per NEC section 51744B, following equipment may be connected to critical equipment arranged for either delayed or automatic connection to alternate power source. The second bullet point, I've got the first sentence highlighted all the way in the bottom left of page 6. In instances in which disruption of power would result in elevator stopping between floors, a throwover switch must be provided to allow temporary operation for an elevator to release the release of passenger. So a throwover switch is just a switch used to give temporary power to get people out, make stuff happen. But as soon as you're done, you open that switch back up and you're using that power for more emergency systems. 113, other healthcare facilities. The whole paragraph is highlighted, the little 113 paragraph. In facilities that do not require Type 1 or Type 2 EES. Emergency power may be provided by batteries in accordance with NEC Section 700. Batteries are required to maintain the emergency load for an hour and a half. Key in on an hour and a half without the voltage falling below 87.5% of normal. These batteries have to keep the facility on for an hour and a half. That's what you want to key in on. 120, electrical distribution systems. Second, third, and fourth sentences are highlighted. To ensure continuous electrical service from the utility provider, hospitals and certain other healthcare facilities are placed on a spot network. Spot networks are considered to be most reliable and flexible arrangement. Ideally, these feeders are installed in parallel so that a fault in one feeder will not affect or produce faults in the other. So that's saying that hospitals are, do I have that picture? No. Hospitals are fed from multiple different sources. So that if one, say a car hits a power line and the power line falls down and that leg of a system needs to shut down for a neighborhood or something, that might also fed a hospital. I know where I live right now in Araby that the line going down my street also goes for the hospital. So a lot of times or I know after Ida, like our power came on very quickly because we were on the line with the hospital on it. But the hospital's also fed from other lines that if my side goes out, that is still feeding that. So that is called a spot network. Down below that paragraph I wrote, spot networks are fed by 2 or more feeders. They go through 121, 122, double-ended system, so that's a different type of system. Alternate power source, so you can have a big diesel generator that could power your system. I know at Nucor we had big diesel generators, not that stinking big, but still big diesel engines that would turn on and provide power for stuff that had to be powered all the time. Ground fault protection 1, 2, 3, last sentence on page 7 going into the next page is highlighted. However, phase overcurrent devices cannot distinguish between normal load current and low magnitude ground fault short circuit current of the same magnitude. For this reason, ground fault detection is used in addition to the phase overcurrent devices to provide protection. Page 9, 124, additional grounding and bonding requirements. Second sentence is highlighted. As specified in NEC section 517.14, where branch circuit panel boards for normal and essential power serve the same patient care vicinity, they must be connected together with insulated copper conductor no smaller than 10 gauge. Another question to come out of that. You got section 1 review on page 9. I'm going to move on to section 2. Section 2 are devices used in healthcare facilities. PowerPoint up. So, second, third, and fourth sentences are highlighted on the page. Devices on emergency power must be easy to identify. This reduces the time wasted in locating receptacles during a power outage. These devices may be identified with a distinct color, such as red, or by labeling. When color coding is used, it must be the same throughout the facility. You might notice if you're ever sitting in a room waiting on a doctor or something like that, different plugs have different color circles on them to signify if that power is going to be restored or not with emergency power. Next paragraph, pretty much the whole thing is highlighted. Devices in a hospital should be mounted so that they are easy to use because a large number of hospital patients spend time in wheelchairs. Particular attention should be given to these requirements. All receptacles should be mounted approximately 24 inches or 2 feet above the floor for convenience of patients and staff. Always refer to job plans and specifications. But most of the time in a residential house, your plugs are at 16 inches. So they're moving that up another 8 inches for people in wheelchairs to be able to more easily access the plugs. 210 hospital grade receptacles. First paragraph, last sentence is highlighted. Hospital grade receptacles are often marked with a green dot on the outer face of the receptacle. So you can see those pictures on the board. They got green dots on them to represent that they are hospital grade. Immediate next paragraph, first sentence is separate highlight. Hospital grade receptacles meet nationally recognized testing laboratory criteria for superior electrical characteristics and mechanical strength. So like underwriters laboratories would certify these as a special grade or a hospital grade. Nothing in isolated ground receptacles. 212 tamper resistant receptacles. This is getting a little bit old because these are these types of receptacles are finding their way into residential settings. But I got a couple of highlights that come out of the first couple sentences of page or in section 212. Tamper resistant receptacles prevent foreign objects from coming into contact with energized components inside the receptacle by only operating when both the hot and neutral blades of the plug are simultaneously inserted. That's just saying you can't shove a fork in one side because there's little windows that shut when nothing's in there. So if you try to push just on one side, both windows won't open up. There has to be equal pressure pushing on both sides of the windows in order to get it in. A lot of people get frustrated with these, but it eliminates the need for like child protective covers or people that don't know what they're doing or anything like that. People trying to shove stuff in outlets protects against that. Next sentence is a separate highlight. These receptacles must be used throughout psychiatric and designated general care pediatric locations. So people that aren't all the way there and babies and children and stuff like that, they are required throughout those places where people can't shove stuff in these outlets. 220 general care category 2 spaces. The first, pretty much the whole paragraph is highlighted. It's difficult to prevent a conductive path from a grounded object. It is difficult to prevent a conductive path from a grounded object to a patient's body in a healthcare facility. The path may be created accidentally or through the use or through instruments directly connected to the patient that act as a source of electrical current. This hazard worsens as more equipment is used near a patient, such as in surgical suites and intensive care units. The more you connect to a patient, stuff like that, the higher chance they are that they are grounded, and you got to make sure that they're not going to get shocked or something like that. Moving on to page 12, so still in the same section of general care spaces. Page 12, right after the bullet points on page 12, first sentence has 2 questions come out of it. In addition to 2 branch circuits, each patient bed location must have a minimum of 8 receptacles per NEC 517-18B1. So that's for a regular general care bed, has 8 receptacles. Critical care or category 1 spaces, 230. So general care is category 2, critical care is category 1. Seems like it's out of order. 230, last paragraph on page 12. The first sentence, long sentence, is highlighted. NEC requires that each patient bed location in a critical care space be provided with a minimum of 14 receptacles, at least one of which must be connected to the normal system branch circuit required by the NEC, or a critical branch circuit supplied by a different transfer switch than the receptacles at the same location. Next sentence, separate highlight. For the NEC, operating rooms shall be provided with 36 receptacles, with at least 12 connected to the normal or critical branch. 36 receptacles. Almost, I don't know why they didn't say 13 and make it exactly half, but 12 of them have to be connected to the normal or critical branch, making sure they're going to come back on when if power is interrupted. 240. Grounding receptacles and fixed equipment. Last sentence on page 13 is highlighted. Type MI and MC cable must have a healthcare faculty rating and clearly marked as such and terminated using listed fittings. If you flip over to page 14, you can have hospital grade AC cable that I don't have a picture of, but there's a picture of in the bottom of page 15. So it's you can see that 12-2 is green, has a green coating on it to identify it. Just have to make sure that those MC and MI cables are used with hospital grade. On page 15, the second paragraph on the page. So you got bullet point, first paragraph, second paragraph. First sentence is highlighted. Equal potential grounding is one method of grounding used for sensitive equipment. First highlight. Rest of the paragraph is a separate highlight. An equal potential ground plane is a mass of conducting material that when bonded together provides a low impedance to current flow over a wide range of frequencies. So low impedance to current flow over a wide range of frequencies. That's your highlights for that. So that's section 2. You got section 2 review on page 16. And I'm going to go directly into section 3. Pull up my last PowerPoints for this section. Section 310, inhalation anesthetizing location. So where anesthesia is used. Second to last sentence in the first paragraph in 310, it's going to have two separate questions that come out of it. In areas where flammable anesthetics are used, the entire location is considered Class 1, Division 1 location up to 5 feet, a level of 5 feet above the floor. So 5 feet above the floor is considered a Class 1, Division 1 location. 311, wiring and equipment within hazardous anesthetizing locations. So, per the NEC, wiring and equipment within hazardous or classified anesthetizing locations must comply with the following. I've got the second to last bullet point in this section on the right-hand side of the page highlighted. Attachment plugs and receptacles in hazardous locations must be listed for use in Class 1 Group C hazardous locations and have a provision for the connection of a grounding conductor. Got to have a ground. 312, wiring and equipment installed above hazardous anesthetizing locations. They go through the different bullet points that you have to follow for those. I do not have any of those highlighted on page 18. Nothing highlighted in 3, 4, or 5. I can see an online test question coming from those whenever we first, so make sure you read through those for the test. 320, low voltage equipment instruments. I highlighted the heading that goes along between the first paragraph and the first sentence of the second paragraph. I've got 3 questions, 2 practice test questions and another question come out of these first paragraph and sentence. Low voltage equipment that is typically in contact with patients or has exposed current carrying elements must be moisture resistant and operate on 10 volts or less. 10 volts or less. Or be approved as intrinsically safe or double insulated equipment. Refer to NEC section 517.64. 10 volts or less and the NEC section are important. The first sentence of the next paragraph is a separate highlight of the first 2. Electrical power to low voltage equipment must be supplied from an individual portable isolation transformer, or auto transformers cannot be used. Going on to the next page, 330, X-ray installations. Last sentence of 330 is highlighted. NEC Article 517 Part 5 covers X-ray equipment. So you need to know that section covers X-ray equipment. Section 331, first paragraph is highlighted. X-ray equipment, whether fixed or stationary, must be connected to the power supply in a way that the wiring methods meet the requirements of the NEC. Equipment supplied by a branch circuit rated at no more than 30 amps may be supplied through a suitable attachment plug and a hard service cable or cord. No more than 30 amps is what to key in on that. Next paragraph in the top right, last sentence, is a separate highlight. Circuits and equipment functioning on a supply circuit over 1,000 volts must comply with the requirements of NEC Article 490. 332, disconnecting means of X-ray installation. Second paragraph is highlighted. The net disconnecting means must be in a location readily accessible from the X-ray control. A grounding type attachment plug and receptacle of proper rating may serve as a disconnecting means for equipment supplied by a 120 volt branch circuit of 30 amps or less. Key in on the 30 amps or less. They go through rating of supply conductors, control circuits, transformers, high tension X-ray cable, guarding and grounding. I've got no highlights in those, but I can see, like you can see, those are filled up with NEC sections, so you might want to read through and have an idea of where those are in your National Electric Code book. Section 340, communication, signaling, data, and fire alarm systems. That first paragraph, last sentence, has two questions come out of it. NEC Articles 640, 725, 716, 800. Shoot, not that sentence. Sentence after. Nurse call systems, figure 10, may use non-electrified patient control. These are emergency pull cords, for example, as an alternative isolation method. So you're using, so you don't have electricity flowing to the patient, you got a nylon pull cord that can call for the nurse. Page 22, 350. Isolated power systems. First sentence is highlighted. Isolated power systems are used to prevent power interruption due to a signal line to ground fault and to isolate power from any electrical ground in certain critical spaces. So figure 11 shows an isolated power system. You can see that panel board right there. Installation of these isolated power systems. 351, second paragraph, second sentence is highlighted. The secondary voltage of an isolation transformer must not exceed 600 volts between conductors of each circuit. Skip the next paragraph, and the sentence before the bullet points is highlighted. Per NEC section 517.168.5, the isolated circuit conductors must be identified as following. I have the first bullet point highlighted. Isolated conductor number 1 is orange with at least one distinctive colored stripe other than white, green, or gray along the entire length of the conductor. So orange with a colored stripe that is not white, green, or gray. Should show isolated conductor number 1. They might ask about 2 and 3. 2 is going to be brown, 3 is going to be yellow, but just so you know, 3 different ones. 352, line isolation monitors. This is what's going to monitor your isolated power systems. Third paragraph, first sentence is highlighted. Monitors must include a green signal lamp visible to individuals in a necessizing area, which remains illuminated when the system is sufficiently isolated from ground. I underlined monitors, and out to the side of it I wrote line isolation monitors. They're just shortening that. This is all my highlights for this module. So you've got section review questions, module review questions. You also have supplemental exercise and a practice test to go along with this. So that is the end of this lecture.